Then what is the feature store? Feature store basically it's a little term. It's a feature storage. You can see in the image that the feature store is solving multiple challenges, uh, latency, feature drift, scalability. So when we talk about feature store, we have multiple advantages using it. So one is consistent way to access feature. So we just talked about, right? There was uh, a, when we have created training and serving SKU, there was a two different way to access the same feature. In the training, we had a training pipeline. In the serving layer, we had the same transformation rewritten. So this feature store, when you use feature store, you don't have to do that. You don't have to write uh, two times your feature transformation functions. Another consistent way is when you are training a model, you are just need to for, for you don't have to think about that it's a real time or it's offline. You have the same way, same API, same method to fetch that feature. Second is reuse of feature. So for example, within a company, there might be a multiple different team, and those multiple different team might be using the same feature. So historically, what used to happen, you have build your features for your model, and there is another team which wants to build a different model but using the same feature. They have to redo all the work. Now they can reuse because of feature store. Third, decouple ML and data infrastructure. So feature store separates this ML part and the infrastructure part. So when you have built a model, you don't have to worry about that how the feature gets computed, how the features will be served. You just need to ask for the feature. And there is a data infrastructure that is a completely separate part that's responsible for facilitating these features. Fourth is feature monitoring. Feature drift basically becomes a very important thing. Their feature drift basically means that your feature distribution has changed. Maybe when we look at the data, for example, in the COVID time, all the data has changed because of the environment. So how can we detect those kind of scenarios so that you get to know that model won't work well? So feature store facilitated this feature monitoring, and when the feature distribution changes, you would get to know that feature distribution has changed. Maybe you need a different model. Maybe you need to retrain it. Fifth is productionizing new features. So, for example, you have built a model historically, you wanted in a few more features. It is a tedious task. But in the feature store, because of it's a decoupled, now you can productionize a new feature very easily. So we have talked about feature store. Feature store sits on the feature engine. So this is the basic architecture of the feature store that we have built at our company. So there you have a data sources, there is a compute server, and there are offline data store, then there is an online Redis. We will talk about what is Delta, what is Redis. The idea is there is a airflow scheduler which will schedule the jobs and will facilitate the data and store those that data into these two stores, Delta and Redis. Now let's talk about Redis. Why online store? Why offline? Why these are two different stores? On when we talk about online store basically is responsible for serving data at very low latency. So Redis is one of such a store where it's basically an in-memory data store. Because it keeps data in memory, it's very fast. It can serve at low latency, and it has multiple other advantages as well. So for the online store part, it is not compulsory that you use Redis. There are other alternative as well. You could have used MySQL as well here. depending on your type of data, or depending on applications latency, you can have used Cassandra here as well. So the choice of online store depends depends task to task and company to company. Coming to the next part, so we are using this Redis as online store. There is a very important part here is how the Redis will store that data. So there is a specific format there are which is used by multiple other feature platforms across the world, and is uh, that is Redis hashes. Maybe if you can read more about Redis, and then you can come to know what is Redis hashes. Redis hashes is nothing but it's a two key level map. It's kind of dictionary basically. So when you use the data format, you need to store the data, and that data store is stored in a serialized format. So now we talked about serialization, right? So why serialization here? Why serialization is important? Why are we talking about serialization? Serialization is basically a way to persist the object state. So for example, when you need to transfer the data, so usually what we do, we write into CSV files, and then we might want to use that same CSV file in some other use case. But usually that's a bad practice when it's important to preserve the state of the data. So for example, if you have a date time variable, it will store, CSV will store is a string, and that string format might have some values that when you read it, you might not be able to read it. So when you want to preserve the same behavior across multiple or different environment, then the serialization comes in. Serialization, uh, there are multiple types of serialization. In the serialization, you basically pass the data and store in a sequence of bytes. And when you try reading in a different environment, you deserialize it, and that state is preserved. Now we can evaluate multiple different types of serialization format, and you can have a look at the table which serialization format is good. When we talk about pickle is really good in speed and type, but the human readability is lost. It doesn't store the schema as well. When we talk about JSON, where it has high speed, human readable as well, but doesn't store the type information. Then similarly, there is Avro, protobuf, and CSV we talked about. CSV is basically human readable, but it doesn't gives the speed or type or any schema based information. So we have talked about what are the challenges of real time, and then how are we solving. Feature store is the method that is solving all these problems. And in that feature store, we are talking about what kind of different storage we can use. We talked about Redis. Now moving to the next part, offline store. So why the differentiation is there? Basically, differentiation is important because online store will be used for the real-time inference purpose, and the offline store will be used for the training purpose. But as a user, you should not, uh, it is not important to you that is it stored in offline store or it's online store. As a user, you are accessing the data. It's the feature store's job that how they plug in the online store and the offline store. Now, are there any questions? Okay, I think there are some of the questions. Okay, so one question is, what do you mean by decoupling ML and data infrastructure? Can you explain? So when I talked about decoupling ML and the data infrastructure, so imagine a scenario. So historically, what used to happen? We have the model, we have offline built a model. and now we want to productionize it. When you say productionizing it, it needs to be in some form of API. And when you have the API, and it needs some feature data so that it can make a prediction. And for example, the example that we talked about, right? That transaction predicting fraud real time. So when you are trying to predict a transaction is fraud or not, you need multiple other data points. Multiple other data points mean that you might want to know that where this request is coming from, what is in that location, what is the percentage of fraud in that location, how many transactions have happened in the past 5 minutes, how many transactions have happened in the last 1 minute. So when we need to calculate these features in last 1 minute or last 5 minutes, it becomes challenging. It needs some kind of computation, right? It needs some server. So that's where you can get the data, process it, and solve it. Because the model is not going to process it. Model is just for inference. You give the data in the right format, it will give you prediction in milliseconds. So that's what I mean. So now the model prediction part is completely separate. The data computation part is completely owned by feature store. When the model will say, give me the data, it will ask the feature store and the feature store will just facilitate the data. So this feature store is independent from the model. The computation is not happening within the model, like with the model. So that's what I mean. I hope that answers your question. How do we use this feature store? Are there any libraries for it? So feature store is basically, yes, there are library. There is a one open source one, Feast, that was developed by Gojek, Google in the collaboration. So there is a library and there is a enterprise solution as well that is based on Tecton. So I hope that answers the question. Can you confirm training always happen offline and never in real time? Yes. Okay. Can you confirm? So it depends case to case, right? Historically, when we didn't know that, so mostly it used to happen offline. Now, in today's scenarios, there are like millions of models that are building and that are being facilitated real time. So these process, this building training models can happen online, like real time as well. So there is no hard and fast saying that training should always happen offline. So it can happen real time as well. So feature store example, convert categorical variable to numbers, get other features for prediction. Yes, exactly. Feature store basically, it facilitates the data for the model. When it's a feature store's job to compute that data, transform that data, collect the data from multiple other sources. These all tasks will be done by feature store on. So model does not need to worry about that. When you are building a model, now you don't need to worry about that. You just need to tell that feature store these are the uh, kind of data that I will need, and you will and this data computation will happen on the feature store itself. Okay, the next question that we have, while training features are different and in production features are changed, how to handle this situation? So when your training features are different and the production features are changed, so this, remember this thing we talked about training serving skew. So for example, let's say you were expecting a column to be a numeric type, and in the production it is coming as you were expecting a numeric and it was coming as a string. So it can come. So for that, there are data validation step. So there are multiple package and solution for it. If you would search what is the data validation for ML, machine learning, you would get great expectation is one of the solution. So what the great expectation does it? It basically store the assumptions about the data. For example, that feature one I need in a numeric format. So so whenever you get this feature, it will always check if this is numeric or not. If it's not in numeric, based on your use case, maybe you would want to convert into numeric, or maybe when you don't have numeric, maybe you would want to raise some alerts. So that is a different part of solution that is also can be plugged with a feature store as well. So I think that answers the question. Okay, thank you for answering. Which framework helps with real-time training? Which framework helps with? I'm not sure what does it exactly mean. So framework is independent, right? For the real-time training, you need basically when you have the data, you basically need to train it real time. And when you train it real time, you need to check that your training was valid, or and it's mostly on the infrastructure part. So when you talk about framework, you need to solve on the infrastructure side. That's what I would want to say. Next question, can you please explain which models are used for training in feature store? And also, can we see the models performance for all the models used in this feature store? So let me clear, feature store is just for features. Think of it like a feature platform. It's not uh, it's not a training solution. So when you want to train a model, either you would have to do it offline, or maybe if you want to do real time, then you would need to go for a different solution. Feature store basically is the go-to for the feature data. It will facilitate the data in real time at a low latency with big scale. It will combine the data from multiple other sources and several others more, but it won't train the model. Okay, we have few more questions as well. Can we real-time machine learning process be used as in web scraping? I don't know what exactly does it mean. So real-time machine learning processes can be used where you have the where you have a machine learning problem, right? When we are talking about machine learning system, the problem has to machine learning. So if it's a web scraping, I don't know exactly how can you use the real-time machine learning over there. You will have to define the problem properly. Which tool can, so Vignesh is asking, which tool can I use for real-time training? For example, Mahout cannot help. Yes, right. Mahout, Spark cannot help. Scikit-learn cannot help. What can I use for training real? No, so you are interpreting in a very different way. So you can use Spark real time. Spark streaming solutions are there. People are using Spark for real time training. Scikit-learn, people are using Scikit-learn using real time. So it's not on the, you need to understand that these frameworks are independent. The important part when you train the model is how do you facilitate this infrastructure? How do you, where should this training should happen? The Scikit-learn or Spark a uh, just a code, right? You need a server, you need a compute to facilitate that. So if you have the compute, you have the compute infrastructure solution, you can train real time as well. There is no problem with Mahout, with Spark or Scikit. What are the differences between features and matrix dimension? Features are basically which when you have observation. So for example, we talked about predicting a transaction is fraud or not. When we talk about attributes of transaction might be that where is it originating from? What is the time? So these are all features for this transaction. Metrics, when we talk about metrics in machine learning mostly used for or when you are evaluating your models. So you are getting confused. Dimension is as same as features as well. Metrics can be as same as features as well. So depending on the domain, it can mean the same thing and different as well. For web scraping, I meant to obtain real-time and fresh data. So for web scraping, if I understood your problem correctly, you can get the fresh data from the web and you don't need machine learning for it. So maybe might want to work on how can you facilitate web scraping. Uh, like it can happen batch jobs as well. You don't necessarily need to do real time. Feature store use case is applicable to polish the production data and reduce latency challenges. Mostly yes, but it's much more than that. It's one that we talked about, right? How to maintain the consistency. You are observing the same data on the offline side and the real time side. It, this is a very big problem that what kind of data that you were expecting in a production that was completely different. So to solve these kind of challenges, you use feature store. Another is uh, feature monitoring as well. Does it mean feature store stores real-time data mining, real-time data mining, wrangling, and then stores to be called up later for any other jobs? Yes, exactly. You use a feature store for real-time data mining, wrangling, and pre-processing, and then store it somewhere so that other services can reuse it. Okay, let's move to next. So we talked about online Redis store, right? Now offline store. So the purpose of offline store is that when you need the data, training data for offline purpose, you are building a model, right? There you don't, uh, there basically you don't have a latency problem. It's fine, and you are fetching a lot of different data. So there you might not need some these solutions ready, because when we talk about these solutions, these are costly as well, because so that's why need we have a different solution for different kind of store. Offline store, you just need a database where you can fetch the data and pre-process it. So for this offline store, you can use Redshift database, MySQL database, any other database, right? Usually, historically, what we have been doing that can come here. Why I have chosen Delta tables? Let's talk about that. Delta table. Delta table provides multiple other examples. Delta table is very seminal solution that was developed by Databricks Spark guys. And historically, what used to happen is that uh, exit transactions were only guaranteed by MySQL based solution. Now, Delta is not a MySQL based solution, but Delta is the innovative solution that provides you exit transactions. It guarantees you, right? When you have the banking transactions data, you need your ACID properties to be intact. So Delta tables facilitate that. Delta table has another property. It facilitates the time travel. For example, let's say you have built a model and you productionize it. And now you want to have a look at the data in the past, what exactly the data was. Maybe something went wrong, you want to debug that. That's where the time travel comes in. So time travel facilitated this debugging and these rollback solutions. It's also a unified batch and streaming solution. So remember, if you do read about what is the uh, So we used to use a Lambda architecture for facilitating real-time data. For not real-time data, when you have a lot of data that is coming at a high rate, and we want to process it and restore it. So Lambda architecture, basically a two-way process where you are using a streaming solution and the batch solution, and maintaining the Lambda architecture is very hard. So Delta table solves that purpose as well. So there are other properties as well. So maybe you can read more about it, and then it will click more that what are the powers of Delta table. Let's move to the next. So this here I'm presenting the ideal architecture. Initially, we have looked at the basic architecture to not to overwhelm with the overall architecture. Now we talked about the basic aspects of it, internals of it. Now we can have a look at the ideal architecture for the feature store, how exactly it should look like. So when you have, let's say you can have two different types of data sources. One is batch data and another one is streaming data. In the streaming data, you can have a Kafka, Kinesis, or on the batch data, you can have Redshift and S3. The idea is you use the batch processing and store the data somewhere, and you are using streaming a solution to process the data in streaming and store it somewhere. Then you have the Spark ingestion APIs, which stores that data in the Redis and the offline store so that it can later be consumed separately. And if you notice, there is a sync between offline and online. What is the purpose of sync? The sync facilitates that the data that is observed in offline online remains exactly the same. It should not happen that offline has a different kind of data and the online has a different data. So sync facilitated that it may ensure that there is a consistency in the data. And Airflow or any scheduler might trigger that sync part. Online Redis will be used for online serving, and the offline store will be used for offline training. So this is the overall architecture. Now we discussed about the challenges and the solutions, how feature store solves them, what are the internal parts of feature store. There is online Redis, there is offline Redis, and we have also discussed what are the benefits and how they are solving these challenges, how they are resolving those challenges. So now coming back, so yes, we can have more questions. Okay, let me get the. Okay, so we have questions. Can you tell the complete pipeline to be ML engineer? Which tools are much more important to learn for facilitating that mode? Complete pipeline to be ML engineer. Which tools? I think focus should not be on the tools. In my opinion, we should think about the different patterns and the challenges that industry has. If you have the model, if you want to facilitate the data in real time, so that means that it needs to solve that at a low latency, right? Then we can think about what are the solutions, what are the tools that facilitate this at a low latency. But if you read about directly about the tools like Redis or Cassandra or MySQL, it will be difficult for you to utilize that. When you start with a problem, so this is my problem, what are the tools available? So there are really big number of tools in the ML landscape. So it's very hard, but you need to think about uh, in the complete pipeline. You have the data, you need to pre-process it, then you need to store it. When you are storing it, it needs to consume for the model. When you look at the system design part, how exactly this is happening, then I think it will be good for being an ML engineer. Okay. How the retraining happens and where it happens and how frequently it has to be done.
Yeah, Ved,
Yeah,
I'm Suchitra this side. Sorry to interrupt you, but let me throw a poll, feedback poll, so that
sure.
people can rate us. Okay, so
Yeah, sure.
just 2 seconds.
Yep.
Yeah, guys, I would like to request the attendees to please fill the feedback poll, as it helps us to conduct more sessions. Yeah, Ved, you can proceed further. Thank
Okay.
you.
Thank you. Okay, so the next question is how the retraining happens and where it happens and how frequently it has to be done. Okay, the first question is how the retraining happens. So there are multiple ways to do retraining. One is if your training pipeline is offline, so then it happen offline. And where it happens. So for example, this is exactly a, when you have trained your model in the development side, when you had a Jupyter notebook or anything, any script or any model pipeline, you first time you trained it, the exactly same way retraining happens. You get the new fresh model, you evaluate it, and if you find that this model is good, then you push into the production. When you push into the production, you have to deploy the API that you have built. You need to redeploy the solution. That's how the retraining happens. And where it happens, I think I already answered that question. How frequently it has to happen. So how frequently, there is a no hard rule, but there are things when it should happen. When the feature drift happens, basically your data distribution is changed. Maybe 6 months ago, your company was operating a different scale. Now it's operating at a very different scale. So then you need to retrain your model. Maybe like you can, if your feature drift is not happening frequently, then maybe you can use the same model maybe for a month as well. Maybe you can schedule your model pipeline every once a month as well. And this retraining happens. I think answered that questions. Can you demonstrate how the feature store is used with a data set? For example, how feature store mines, transform, pre-process. Okay, I think I discussed already this the ideal architecture where feature store, basically think of it's like an SDK. You use that SDK, and that SDK is used to access that data. So how the feature computation gets happen? There is a basic architecture that we have seen, right? There is a scheduler. Scheduler will schedule the jobs, and when the scheduling, after scheduling, when it runs, it will store that data into the feature store. So that's how it happens. When you say, Shovik is asking, when you say training can happen in real time, assume you mean the best model has already been chosen by validation, cross validation previously. What's happening in real time is training that model with the latest data to update the posterior probability. Yes, that's correct. So model selection can also happen. Uh, so model selection can also happen real time, because it is not necessary that the model that you have chosen today, for example, you have used logistic regression today, and after 2 months down the line, you would believe that only logistic regression would work better. That is not correct way to say it. The model works best on your data today. It might happen that tomorrow a different model can work better on your data. So it will depend basically on the data, and you would have to try it out. Decide on the feature store. Okay. Mm, okay. How do we identify feature drift using architecture shared? So there are multiple modules or multiple logics in place that we can reuse. So there are multiple feature store solution in the market. Some uses the feature drift solution, some don't use. Basically, it's nothing but you have the data distribution that is, let's say, you have the data for today, you capture the data distribution statistics, and whenever you have incoming data, you match this data distribution statistics. If it's significantly differs, then you might raise an alert, or maybe you can identify that your feature distribution has changed. So this is the way you can use. So maybe you can try googling how to check data distribution, how to check data distribution statistics based on samples. So you will get the answer. I think I've answered all the questions that were posed. Uh, yeah, thank you. Thank you. It was a great uh, uh, giving session on this important problem today.
Yeah, thanks a lot, Ved Prakash. On the behalf of Analytics Vidya, I would like to thank you for your time and delivering such a wonderful session. I'm sure our audience found it insightful, and hopefully we can conduct more such sessions with you in the future. I hope you guys filled in the feedback poll. If not, I request you to please fill the feedback poll so that we can conduct more sessions like that. Okay, guys, thank you so much. So we are ending the session. Okay, thank you. Thank you, guys.